Welcome to homework.
Hello, my name is Margaret, and today I'm going to be helping you with Zoomdal Chapter 18 Electrochemistry, problem number 27. And the problem states the free energy change for a reaction, delta G, is an extensive property. What is an extensive property? Surprisingly, one can calculate delta G from the cell potential E for the reaction. This is surprising because E is an intensive property. How can the extensive property delta G be calculated from the intensive property E? So let's just start out by talking about intensive and extensive properties, which are covered way back towards the beginning of Gen Chem, where we're talking about properties of different parts of matter or different types of matter. And so extensive properties are properties that depend on the amount of matter being measured. Okay. And examples of this are some of them, there are some of the more obvious ones like, mass, length, volume. But obviously, there are some of the more tricky ones once you start to get into some of the really more intense types of properties as you get further in. So there are things like, for example, some things that we've covered in this chapter, work and charge are, and then obviously delta G are examples of properties that are extensive as well. Intensive means that it doesn't depend or it doesn't matter on the amount of the amount of matter present. Ooh. For this particular property. And examples of this are, obviously cell potential, density, things like this. So now here's something very interesting, and this is kind of the key to understanding why this particular problem works. And it's not something that's mentioned in the answer in the textbook. I don't know about the solutions guide, but when you have a ratio of two extensive properties, you get an intensive property. And density is a great example of this. You ratio mass divided by volume, and all of a sudden you get out density, which is something that doesn't change depending on the amount of things present. Okay, so knowing that, okay, let's take a look at some of the equations that relate delta that kind of show how we ended up relating delta G to cell potential, okay? So we initially started out with the cell potential, E, equaling negative work divided by charge, okay, where this was work and this was charge. Okay. And these were both, I will label them with I's, or I'm sorry, E's, because they were, wow, ooh, sorry. Label these because they were extensive, right? And we can see coming out of that we ended up with an intensive property, cell potential, right? So we eventually rearranged this to become work is equal to negative QE, right? So now we have extensive on one side Pen doesn't want to cooperate with me today. All right, so we have extensive on one side, and now we have an extensive and an intensive. Now then, we decided that we were going to say that Q charge was equal to N, the number of electrons, and multiply that times F, which was Faraday's constant. In order to get rid of the time component that ends up being held inside of Q, so that way we can solve problems easily. So now, if we end up substituting this in here for Q, we end up with work is equal to negative NF E. Okay. And just because we've done a substitution in here doesn't mean that this all of a sudden has become intensive or has changed. This is still extensive. So we have extensive over here, we have extensive right here, and we still have our intensive property right here. Okay. And then we ended up saying that when we have work at max, that gives us delta G. And so then we substituted that in here. So we have delta G is equal to negative N. That looks not like an N, sorry. Negative NFE. So we have this component, which is still extensive. And we now have delta G, which is also extensive. And we have E, which is intensive. And so this is how you can end up with an intensive property giving an extensive property. It's because you've ended up taking the you're multiplying the intensive property by the one of the other extensive properties that